I have been promoting an idea to reduce the intensity of hurricanes. And the way you would do that is you get a pump, and the hurricane gets all of its energy from the warm water surface. So what you want to do is cool it down. Well, where do you get cold water? Go down. Because if you go down in the ocean, water gets 4 degrees, 5 degrees centigrade.
So these are standardized.
So if you can bring it up, pump it up somehow in the middle of the ocean, you can cool the surface, and you won't have any hurricanes anymore.
This is a great day. This is a culmination of the capstone event for the seniors. They've worked very hard for 4 years in their design projects, and finally they get to see the fruits of their efforts and their labor. Everybody has a great project here. They're very, very proud of it, and they are well ready for industry, and we're happy to send them on their way after today.
The purpose of the project is to demonstrate robotic capabilities of a urban combat platform with a military theater in mind. Now, currently in use, there's various combat robots, but they all have various limitations in the theater. Particularly, the larger platforms cannot climb stairs, whereas the smaller stair-climbing platforms cannot hold very large payloads. So we wanted to essentially make a platform that can incorporate the best features out there into one integrated unit. Now, on the platform, there consists of 2 caterpillar tracks, and each one independently actuates depending on the terrain that you're attempting to tackle. As you can see, for lowering the center of gravity, you can slam the robot all the way to ground, and you can actuate the arms upward to get higher ground clearance when climbing stairs or navigating high obstacles in the theater. Currently, the applications for this are specifically targeted for an urban environment where there's steps, high grades that you have to overcome, curbs, obstacles such as that, and it's also designed to fit through hallways. And the biggest problem right now in Iraq is that the stair angles are much higher than the United States stairs. So this platform has capability to tackle that problem. Now, we also have a vision system attached to the robot. You want to look over here? All right, so we have a vision system that can target a user-selected object and continuously track them through varying backgrounds. This uses a probabilistic model and 3-dimensional histograms to identify targets and track them when the colors of the background are very similar to the object being tracked. This has applications in weapon targeting, autonomous surveillance, and also stationary object tracking when your platform is actually mobile and shaking around.
So this is our autonomous swarming robot platform. Basically, it's a single swarming robot at this point, which we've developed all of the custom hardware for. If you can see on the poster here, we have the circuits all the way from conception, board layout, and then physical design. We built it with modular interconnects on each board so that they can easily snap together. This also means that currently we have infrared and sonar sensors, but if you wanted to swap out the sensor load, it wouldn't be a problem. It would be much easier than developing the system again from scratch. You can also see tank treads on the robot, infrared sensors here, sonar. The robot itself runs off an ARM7 processor. It has an FPGA on board for image processing and quadrature functions. Sensor has Zigbee wireless, which eventually will be used for mesh networking capability in for the swarm intelligence.
You know, if you worked at a convention where you was representing a company, right, where the conventions go on, as the one I just came back from Las Vegas, that and you see as the largest conventions in the country, 150,000 people. Have you been to the Javits Center? You ever been to the Javits Convention Center? Yeah,
They have a car show there, right? Don't they have like a car show there? Or something?
And I can't give you a relative.
Basically, our project today was to do market research for a newly incorporated company called Instream Media. A little bit about Instream Media is it's a new advertising technology where you're interactive. So when you're viewing a video through Instream or through your computer, you'll be able to receive information brought back to your email or your SMS text. If you want to do a little demonstration right here, say you're watching the Food Shopping Network and you're interested in learning about products basically within the screen, you'll be able to click right on that, say that cooking sheet. Oh shoot. You can click right on the cooking sheet and it will return information back to you. And then if you want to find out more information about that, about where you can locate it, how much it costs, you'll be able to click right on that cooking sheet and it'll bring up another tab and you'll have information brought right back to you about whatever product you're interested in. Our company did, or what we did for this project, we did a market research report. So we did customer surveys all around campus, and we really received a lot of feedback on if people would actually use the product, if it would be beneficial for them. And then from there, we've expanded now to completing a competitive analysis. We looked at the whole market of online advertising and compared all the different advertisers that are currently out there and what they do, whether it be pre-roll, mid-roll, whether you can actually interact or not. And we've really figured out that Instream has a differentiated product in the market, that they're going to be able to differentiate themselves on online advertising and relay product information back to the consumer.
The vehicle was only a forward and brake control arm. Now it's a forward, brake, and reverse. We have the reverse capability. So now we have like this forward, this is braking, steering, and then we have the option of electric.
So this is to be built next year then?
Well,
Next scale?
I don't think so. I think what we want to do, because another thing that we're doing is
we're going to send a proposal to SAE, telling them like, you know.
I'm glad I'm not a judge because there's so much excellent stuff going on here. I would have had a very hard time in trying to decide which one is the best. Every year is getting better and better. A lot of innovation, a lot of professionalism, a lot of research behind what students do. It's totally impressive. It's awesome, right? Having a team which is multidisciplinary and having to deal with a deliverable, having to look at the systems level, which is very, very complex, you know, to put together a system that then has a market value and look at the whole life cycle of technology development is a unique experience that our students here at Stevens get.
Our project is called Pandoras Box. It's a hardware-based encryption device, and all the hardware encryption is actually done on a board instead of on a computer or a laptop. Most encryption methods today are done with software that's done on the computer itself, which hogs up system resources. It takes a lot of time, as opposed to ours, which does it in real time, and since it's not on the computer, everything's done on the board. It happens like that. And actually, if you want a demonstration, we can type something over here so that someone could type that back. And in this case, either computer can act as the encryptor or the decryptor. And basically what this means is that a hacker has to, if they really wanted to break the system, they'd have to physically take the device. They'd have to figure out the interaction with it, because there's several different flavors or different types of VHDL, which is the hardware description language that we used. They'd have to figure that out, then they'd have to figure out how to interact with it, then figure out our algorithm. It's a really long and complex process. It could be done if they had an awful amount of free time, but no system is really 100% safe. But ours is, it's one of a kind. It's one of the first hardware-based encryption things out there.
We designed an expandable intervertebral cage. An intervertebral cage is used for a surgery called a spinal fusion. Spinal fusion is usually done in the case of a either degenerated disc or a slip disc. In this case, here we have an example spine. You have your two vertebrae, which are bone, and in between each vertebrae is an intervertebral disc. That's made out of cartilage. And over time, this disc can either degrade or it can herniate, causing intense pain to a patient by either losing the height or impeding on the spinal cord. And one option that surgeons use to relieve this pain is to put in an intervertebral cage in which a portion of the disc, as you see here, is removed. In this case, they're removing the pain generator. And they implant an intervertebral cage, which reestablishes the height that they would lose if they left this open. And they also pack it with bone graft so that these two vertebrae fuse, becoming one single unit. You do lose some range of motion, but the pain is gone, which is a great benefit for the patient. One problem with the surgery is that these cages today used fixed heights. So in that case, the surgeon will spread this space up to 15 millimeters, take a cage that has a height of 15 millimeters, and those cages are generally just, hollow cylinders. And he will place it in there. And during that placement, he abrades these end plates, causing a lot of wear on them. And that can lead to other complications such as failure of the cage because the motion is too great to promote fusion. And the cage can actually migrate either into your abdomen or backwards into your spinal cord, causing paralysis, in some cases death. Our solution for this problem is to create an expandable cage in which the surgeon will expand the disc space, place the cage at a collapsed height, in our case 10 millimeters, and by simply turning this insert 90 degrees clockwise, he can expand the cage to whatever height he wants between 10 and 20 millimeters. And those heights we chose because they match up to the average measured intervertebral heights recorded in literature.
And he could adjust it if the person was off.
Yeah. So, regardless of if he can distract it, and he can even use this to expand, the final millimeter to get a really snug fit, so this cage is not going to pop out.
Right.
Our final design also has some teeth to anchor the cage into the end plate, and also has shapes to match this natural concavity of the vertebrae, and the natural shape, which is a D shape.
Vibrate, she's creating electrical energy. You can see the electrical energy in the volt meter right there. Each foot strike generates about 100 millivolts, and this energy will be stored during the day in a capacitor. And once it gets up to 5.3 volts, which will take about 20 steps to do, it would store that energy, and at night it would go into protection mode. And that energy that's stored during the day is to send a wireless signal at night. And the circuitry hooked up there, and each foot strike generates that voltage gets stored in the capacitor. As you can see, the deflection in this 4 tiles is about 1.5 inches, which is way too much. But in the final tile, there would be about 1/2 inch of displacement, which is similar to like a carpet. And the entire floor would be made of these tiles, not just a single tile. So
we worked with Rising Tide Capital, a nonprofit based out of Jersey City, New Jersey, in the Martin Luther King Boulevard area in Ward F. And they help people grow and start their own businesses, focusing on rehabilitated drug addicts, previously incarcerated people, single moms, and a lot of minorities that often don't get the opportunity to start their own businesses in such areas. We helped develop a marketing plan for them, which includes an advertising budget. In order to do this, we surveyed their graduates, which was about 120 people by phone. And when we surveyed them, we asked them about behavioral information. What kind of public transportation do they take? Where do they take it? How often? So that way, when we give them the advertising budget, we're able to recommend specific components of NJ Transit. So instead of saying just spend $2,000, we know, well, you should advertise on this bus line this many times a year for this long. We had a group of 7 working on this project. All of us are business and technology majors in the House School of Technology Management at Stevens. And here we have Joanne, Catherine, Johanna, Jen, Tim, Swati, and myself, Nicole.
We have a press book which shows various things that Rising Tide has done and has got noticed for. We created a booklet So we have all our research and stuff like that, along with the appendix, which shows a compilation of all the data that we put together in the report. The following is just showing the company mission and what they're about, some of our research that we've gone through. We put together basically background information of the students that are currently in the Community Business Academy, and also we have a low budget and high budget because we've developed a sort of a marketing plan for them to follow. So if anybody picks up this booklet, they can look through it and sort of understand how we came about going through and making a marketing plan for them. And so this just shows some of the budgets that we've gone through. And also we came up with basically deliverables for our project and what we recommend they do in the future, as well as possible expanding on other projects for the year after. So if they wanted to get in after marketing, concentrate on expansion and do the mathematics and analyze information behind that. And so we have basically a map of all the organizations and also the students that are currently in the program. And basically just a background and basically our analysis of the program and how we can make it better.
Then you need to talk to him one more time after this, and an opponent will spawn. All right, now he's behind you. There's the opponent, and to attack, you use the various mouse buttons. That clanking sound is parrying. If the weapons collide, it will react by both of the weapons going back and no one taking damage. Yes, the different swings are, this is a right swing, left swing, and the middle button is a thrust. And if you look, it's hard to see from where you are, but if you look down, you can see. And he disappears when you've defeated him, and that's pretty much all there is right now.
The purpose of it should be an aerial surveillance vehicle that the military could use to send into a hostile situation to really assess it and see what's going on. You know, instead of sending in soldiers and risking their lives, you can risk a $1,000 robot. Yeah, yep, kind of like that. The entire year, yeah. Last semester we did the planning, design, and all that, and then this semester was construction. Yep.
And are you mechanical?
Yeah, all of us. Yep, all of us are mechanical.
You have jobs?
Yes, I do. I think everyone does. We have offers. It's close enough. Yep.
What kind of industry is looking for mechanical?
Pretty much all kinds. Really. Yeah, I'm working for Lockheed Martin, so that works.
I'm going for the aerospace industry as well.
The overall take on the day is every year the presentations, the projects get better and better, more and more sophisticated. I was telling somebody earlier, this is every bit as sophisticated as a professional trade show. I mean, you're seeing devices and inventions, products that are ready for prime time. They're ready to go out into the market, and very impressed.